Hey folks, Lanham here. Hopefully you enjoyed the video on how to pronounce Uranus, however you want to say it. I've always said Uranus. My teachers have said that. I don't know. However you want, but it's a fun one, right? So let's talk about the last two planets in the solar system. Sort of. Give you a hint. They're not exactly the last two planets. We have more to talk about that we'll talk about next week. And I'm not just talking about the dwarf planets. So it gets interesting. Astronomy changes a lot. That's one cool thing I like about teaching astronomy. Okay, history lessons. 1781. We were in the middle of the Revolutionary War. I always thought we'd given up England gave up in 1781. According to Google, I didn't look much. I'm teaching science, not history. I think it was 1783. But anyway, the time period. We got presidents with wooden teeth who are opposed to the two-party system and, all the good stuff back then. So there's the time period. There was a British guy by the name of William Herschel that built a really big telescope. And it was actually in the video that we watched before this. If you didn't watch it, go watch it. How to pronounce Uranus. He built this huge telescope and discovered what he thought was a comet, but turned out it was a planet. This is the first person in history to discover a planet. Mercury, Venus, Earth, Mars, Jupiter, Saturn, those are all visible with the naked eye. They've been known since forever. This guy was literally the first one to find a planet, to discover a whole new planet. I mean, that is cool. Embedded in this, I've got the video that I had you all watch, but I'm going to skip that because hopefully you've watched that already. Uranus, smaller than Saturn, it actually rotates on its side. We believe there was some sort of massive collision in the early bombardment that knocked it on its side. So if you're standing at the North Pole, the sun would just kind of go around all the time along the horizon. If you're at the South Pole, same thing. It's actually like 89 degrees or something like that. That is nuts. It's the only planet that does that. It's cold. Uranus and the next one are known as the ice giants. Jupiter and Saturn are known as the gas giants. These are known as the ice giants. It is not massive enough to squeeze hydrogen into that liquid metal that we talked about. So there's no liquid metallic hydrogen. And methane, natural gas, cow farts, etc., that is what gives it its blue color. The planet, like I said, it doesn't have that deep, that liquid metallic hydrogen. So we basically have heavy element core, rocks, metal, and then a mixture of ice and rock, and probably water ice, bigger than the Earth. Most of the water in the solar system ended out in the outer reaches because the inner reaches where we are, it's too hot for water to condense. So our first really good view was from Voyager 2 in 86, and they were surprised to find it had rings. You could not see them from Earth. You could see it when you got close up. They got details of the moons. They mapped out the magnetic fields, which tells you a lot about the inner part of the planet. But those rings are too unstable. They're not going to stay there. So unless things are impacting the moons and fragmenting and contributing to the rings, they'll disappear. But they're there, so impacts are still happening, even though it's not the heavy bombardment. There's this cool little, I I guess you could say, tradition in astronomy. We're only supposed to name some things after certain things. When we did the Pluto flyby in 2017, they came up with the concept that sci-fi things, science fiction, and things are supposed to be what we name the surface of Pluto. And it's not just that, but there is like an enterprise. I can't remember if it's a canyon or a mountain or what, but they've got some more modern kooky names based on some stuff like that. I think there's the TARDIS planes or something from Doctor Who, but the moons of Uranus are supposed to be named after Shakespearean characters, so that's kind of a cool tradition. Miranda is obviously from that one play about Shakespeare. But this one is completely fragmented, and this is one moon that we believe was shattered into pieces, and then the gravity brought it all back together to form a roughly spherical object. One of the interesting things about it is every time they calculated the orbit, it didn't match the math. And they were really confident on the math, so they figured, well, if it's not the math, maybe there's something else out there affecting the orbit of Uranus. As a matter of fact, that's exactly how we discovered Neptune. There's this English guy, Adams, who calculated it. Another French guy actually pinpointed exactly where it would be. So we found this planet based on mathematical predictions. And if that doesn't tell you something about Newton's law of universal gravitation, then, I don't know what will. So this is a picture from Voyager in '89. They found it had very high winds. I think these are the highest winds in the solar system, either that or Saturn. But they go backwards around the planet. I don't know if they've got a reason for that yet. It's also blue from the methane, but there's crystals of methane, which means it's really cold. I cannot emphasize that enough. Where the methane actually crystallizes, goes solid, and those crystals high in the atmosphere will reflect the white. It took this famous great dark spot, and images from Hubble show that it doesn't seem to be there anymore. But these are the best images that we've got. And that was from a flyby. They did discover it also has rings. So all 4 of the Jovian planets, all 4 outer planets, have rings. Saturn is the one you can see from Earth nicely, but they do all have rings. Its most prominent moon is Triton. It's got a really thin atmosphere, little, nitrogen, methane, cold. Not a whole lot is known about it. All we really know about these mostly is flybys from the Voyager probes. We've not sent anything out there. And it wasn't until 2017 that we sent something in that direction, and that was specifically for Pluto, which we'll get to next week. Thanks for coming.